So before we start with today's session, can someone share a recall of what has been done last week?
Cluster role binding we thought about, and service accounts, PVC, PV,
Okay.
right?
Right. So any doubts on that? Did someone complete the assignment?
Yes, Lavanya. So, will there be any session on node affinity topic? Because I have a doubt on that regarding node affinity with storage class. I mean, like if there is any node affinity restriction to a pod, then how the NFS will be reattached with it? Like, do we need to manually attach it explicitly, or how it happens with the underlying carpenter? Because there was some special new feature while I was creating the EKS. There was an underlying carpenter attached to it internally, and so it will create the nodes automatically. So I had a doubt on this.
Okay. Yeah, we can cover it. No worries. Let's see if time permits today. We can cover it by the end of today's session or maybe tomorrow. Let's see how we can.
Okay. Yeah. Thank you.
It will take some time, so I don't want to jump into the questions at the moment.
No problem.
Cover it later. But for sure, we'll cover the node affinity and node selectors. And I think we have to understand the topologies as well. So let me check the agenda and adjust accordingly.
Yeah, sure. Thanks so much.
Yeah, good that you have tried. But did you try to create any CSI driver? And custom
class? I tried NFS like EFS driver. I installed that, and I tried attaching with RWX execution.
Okay. So
yeah, one thing what I explored is with EBS we can't do RWX, whereas only with EFS we can do RWX.
Yes, not all the storage type supports that read write many. Yeah, so you'll have to use the specific class whichever is supporting. So that will be one of your customer requirement if they have a requirement to have a read write many. So it's purely based on the application requirement that you'll have to decide, and then there are a lot of storage classes that supports. So in AWS also, as you said, and in Azure also, we have file storages, supporting that.
And one more doubt, I didn't understand the difference between the default storage class and the standard storage class.
Okay, so basically, if you don't have any storage classes created apart from the default ones, so then I think your standard will be claimed as default. But if there are multiple storage classes that are available, so whichever has the label default class is equal to true, so then that is set as default storage class. But you can set any storage class as your default storage class. So for example, if your company majorly they are using read write once, then you can create a storage class or you can use a default storage class. So if you are going to use a custom storage class for most of your application, then you can enable that annotation or label that default class is equal to true, which means that will be your default class.
So it depends on the provisioner basically.
Yes, so it depends on your settings. So but once you set it, you cannot just like that change the storage class for any of your volumes. So because it's all tied to the storage class. For example, if you have provisioned 10 volumes by using a storage class, but tomorrow if you want to change the storage class for those 10 volumes to different one, that is not possible because it's a complete tear down scenario. So you'll have to plan for a migration in that case. So take a snapshot of the disk and then restore it. So that's how you'll have to do. So the disk migration will be involved if you do any changes to your storage class. So while designing, you'll have to be careful that which storage class you need for your application and then make that as a default. Majorly used one will be your default storage class.
Yeah, got it. Thank you.
Good. Then I think we can start with this week's session. So we don't have two different sessions targeting this week. So basically, we are doing only one. Majorly, we are focusing on controllers, Ingress controllers. So starting from basic to service mesh controllers. So basic to advanced controllers, I would say. So on the fly, we will see what and all tools we can cover in this ecosystem, and yeah, take it further accordingly. Okay. So question here. So what are the type of services that we have in Kubernetes, default Kubernetes services?
ClusterIP, NodePort, load balancer, and external Ingress.
So the one is NodePort. So what is the use case of NodePort? So when it will be used?
If we want to expose our application with the port number from externally.
Okay, externally or within your network?
Within our network?
Right. Basically, NodePort is not an external means of accessing from your public network. Okay. So basically, NodePort is nothing but accessing your application using nodes IP, node IPs. Okay. So when you create a service as NodePort, what it will happen? So for that node, specific range of ports will be mapped. So about 30,000 to 32,000. So within this range, port will be assigned randomly for your services. If you don't mention any port, then it will pick up randomly. If you mention any port, then that port will be mapped. So for example, based on your node IP, you can access your application. But it's very hard to replicate it in our kind cluster. But using the IP, you can access that application. So far we have seen port forward, right? So port forward is one way of accessing the ClusterIP services, but another way is using the node IPs. So using the node IP / colon your port, whatever is mapped in your application, that port you can access, and then your application will be accessing your node within your network. Okay, using the node IP. So that's called NodePort. So for some of you who don't know what's NodePort, just a brief explanation on it. But is this going to be your for your production grade? For your production, do you think your application will be mapped against NodePort service?
No.
No, right?
Because we have to open so many ports.
Right. And so many ports, that's one thing. But how will you give this access publicly? So you cannot give that in sales, right? It cannot be accessed outside of your organization at all. It will have to be on your network. So that's not possible to access outside of your organization, outside of your network, I mean. So in that case, you will have to definitely use the third service, which is called the load balancer, right? So that's the use of load balancer to expose the application outside. So by now you are very familiar about what's ClusterIP, NodePort, and load balancer, right? So using load balancer, you can access your application. So now tell me, I have 10 different applications running on my cluster. So how many load balancer I have to use?
We can have one. One is enough.
Okay.
We
so
can
by
use
default,
services.
one is enough. So if one is there, means how you will map different applications?
Using Ingress and backend within that, we can map services to paths, different pod paths.
So that's on the for that you need an additional service, right? So
Yeah.
by default you cannot do that. So but within without going for any external service, can you do that? No, right?
No.
So the problem will be for every service, you'll have to expose it as a load balancer service, right? So that means if you have 10 application, 10 load balancer will be added. So each and every load balancer will be mapped to a separate public IP, right? So each and every public IP is incurring cost. And then not only the public IP, so you will have the traffic flow cost as well. In ingress and egress cost will be mapped. So that means the cost will be very huge. So having multiple load balancer within your cluster is going to cost more than your cluster cost itself, right? So that's not going to be your ideal scenario. For that reason, we have other solutions to tackle this. So far, it's clear, right? Yeah, so let's go with that. Let's move on to the agenda for today. So today we are going to explore more on this load balancer service, and then we will see what is meta load balancer, and then we'll start with a basic ingress controller, which is Nginx, and then we will start with service mesh with Istio. Yes, Priyanshu.
Ma'am, can you just quick explain like when to use the load balancer and when to use the gateway API? Like, or we will use the like simultaneously both services. Actually, I'm little bit confused about the gateway API. That's why I'm asking to you.
Yeah, we'll come to that, Priyanshu. So
Okay.
just wait for some time. So we will cover. So eventually we will start with the basics, right? So now we are at just the load balancer. So then we'll eventually move up to ingress controller. So at the end of the session, if you have any queries, just raise it. If it is not addressed, we'll clarify it. Okay. Yeah. So this is just a quick recap of what we discussed now. So we have 3 different types of services, right? So with ClusterIP, you cannot do anything outside of your cluster. It's just within your cluster. So only cluster knows the ClusterIP. So NodePort means accessing with NodePort. Okay. And then with load balancer, you have to have a separate DNS mapped to each and every load balancer IP. For example, I have 10 different public IP. Then I have to map my DNS server to 10 different URLs, 10 different IPs. So just imagine how complex it will be if your application grows. If I have 100 application, 100 load balancer, 100 DNS management, so it's going to be a hectic task for your operation team to manage. So that's the major drawback of this load balancer service. So just using Kubernetes is not going to solve the purpose. So that's why we need to have a lot of external tools to solve these problems in a cost efficient way. And then also to avoid the operational overhead, we have to have multiple different tools. That's the complexity of Kubernetes. So everybody can learn Kubernetes, but the entire ecosystem should be known, so that we'll design the cluster accordingly, and then we'll have a very less operational overload. So yeah, so that's the thing. So that's why we are going to look at all the ecosystems covering Kubernetes. Okay, so I think we have already discussed a load balancer drawbacks. As I said, if you have number of services, number of load balancer will increase, and again the inflow and outflow will incur additional cost. Okay, and then again DNS management will be a problem, and again scaling your application will be a bottleneck. At some point in time, even your DNS management will be hectic. So that is one of the major drawback of using load balancer service. And then you, for example, if you go for a DNS management, then you will have a vendor dependency there. So how many DNS management, and then how many public IPs, from where you are going to get the public IPs. So all these will have a vendor dependency. So that will be a problem. You cannot just like that switch your vendors from AWS to Azure or GCP. So just like that, you cannot switch. So that type of dependency will be there. And then each and every load balancer provisioning will take at least 5 minutes or 10 minutes. So that's what I have seen. So not just it does not spin up on the fly immediately. So and then the IP address management. So if you delete a load balancer, your IP is gone. So you'll have to be very careful in managing the load balancer IPs. Okay, and then Another thing is it's not available in the bare metal cluster, so self-managed cluster. So for that, you need to have additional tool called Meta Load Balancer. So that is only managing your IPs. So in which range of IPs your load balancer will be assigned. So load balancer means nothing but an IP, right? So you'll have to define from which range your load balancer IP should be provisioned. So that is done using Meta LB. So we are going to cover Meta LB today in detail with lab as well. So starting from load balancer to Meta LB, and then maybe tomorrow we'll start with traffic control with service mesh and see what different types of traffic routing possible with Istio and why we will choose Istio over Ingress controllers, and then what's the advantage of using Istio over other control mesh. So all those details we'll see. And then what type of routing is possible between these Ingress controllers. So all these details we are going to see this week. Okay. Again, quick comparison for the load balancer is one is Ingress with so it has basic options only. You don't have advanced features like circuit breakings, timeouts, read writes, canaries. So all these options are not available by default Ingress. It is available in service mesh Ingress controller like traffic, Istio, and console. So there are a lot of tools that provides, but behind the scenes, the concept would remain the same. So we are going to look at this Istio, and then in Meta LB also we are going to see. So, yeah. With that, so I just want to give you a notice that this Ingress Nginx controller is in deprecating phase. I think in March they are deprecating. So we'll have to do a migration if someone else is already doing. So why I am covering Nginx? Because that's widely used even now in most of the production as well. So, and also it is very easy to grasp when you are a beginner. So just understand the concept with Nginx Ingress, then you can switch back easily to different Ingress controllers like Kong, or even Cilium is also an Ingress controller. So you can use Cilium or Calico. So all these provides Ingress features. So you can just migrate your Ingress controller from Nginx to anything else, whichever is applicable based on the organization needs. So what they are having in the cluster. So based on that, you can decide on and then do a migration. But we are going to cover Nginx. Okay. And then for service mesh, we are going to cover Istio gateway. And so why they deprecated Nginx? Yes, Ganesh.
So yeah, maybe I think you already started that question. Why they deprecated Nginx, and also what will be the use case for service mesh, Istio, and these things. That will be helpful to understand.
Sure. So basically, this Nginx, if someone has worked on a production, managing an Ingress, so because this Nginx Ingress usually is a tool which comes with a lot of vulnerabilities. So every time if the vulnerability is detected, it's on the Nginx. You'll have to always do a upgrade for the Nginx every month, I would say. So that's one thing. And also the Kubernetes community itself is driving towards Gateway API. So they are promoting Gateway API instead of Nginx. So that's why it's been in deprecating phase. And this is not just announced this year. So it has been already notified last year itself, I believe. So due to the manageability, and also Kubernetes community itself has been focusing more on Gateway API rather than Nginx API. So that's why it has been in deprecated phase, and so this is going to be a lot of work in all the organization. If they are using Nginx Ingress, they will have to migrate to other controllers. Okay. So maybe we can give a lab assignment on exploring some other Ingress apart from this, so that we'll come up with more questions. And also there are a lot of paths available for migrating Nginx Ingress to some other thing. So I would suggest everyone to look at Cilium as one of the alternative for Ingress controller. I mean basic Ingress controller. So as a replacement for Nginx, you can just consider Cilium as your Ingress controller. So maybe try to do a task around this. I will also drop it in the WhatsApp about the task for the Ingress controller migration with Cilium. Okay, so that you will get better. And yeah, and also I will give more details on gateway API. Okay. So let me start. Did anyone created a load balancer service in bare metal cluster? In kind cluster, I would say. Did anyone expose it as a service in kind cluster?
No, Lavanya.
No worries. I'm going to create a new cluster. So the lab details are there in week 5, readme file. Can go through this. I'm creating the kind cluster. So I mostly today's session will be mainly based on the lab. Okay. Yes, someone
Not seeing your screen. I see only the slide. So
said. Okay, let me reshare. Thanks for notifying. Is it visible now?
Yes.
No. So I'm creating the kind cluster. And then we are going to create a simple deployment with image Nginx. And then let's try to expose it as load balancer and see what's happening. So I've created an Nginx deployment.
Ma'am, may you please increase the font size if possible?
Okay. Is it okay?
Yeah, thank you.
Thank you. So I'm going to expose it. So there are multiple ways to expose it. I'm going to use a declarative way. So what's the declarative way and then imperative way? Sorry, I'm going to use imperative way. So what's the difference between declarative and imperative?
We need a YAML file in.
Yes. If you use a complete YAML file, that is your declarative way. If you use kubectl command, that's going to be your imperative way. So what's the drawback of using imperative way?
Like 10 to manual changes, not trackable.
So you no track, right? So there is no YAML. There is no way of controlling it. So in any production environment, you will never use kubectl to create anything. So you'll have to always rely on YAMLs, and you don't even apply the YAMLs with kubectl command. So we will see how it is automatically applied using some tools like Flux or Argo CD. So we have a dedicated session. So next session will be based on that, how we are going to make use of the declarative approach to sync all these YAMLs. Okay. Now, so if you see, I've created a load balancer. So in the kind cluster, it's not able to provision the load balancer IP. Any idea why?
It doesn't have a load balancer config
Right.
within local system.
So basically, load balancer is nothing but your public IP, right? So to provision a public IP, you need some place to create a public IP. So if it is an Azure, it will be created as an Azure public IP. But if it is in kind cluster, we are not able to create, right? A kind cluster or self-managed cluster, there is no mechanism to assign IP address by default. So for that, what is the solution? Any idea? So we'll have to use a service called Meta LB, Meta Load Balancer, which is going to help me to assign the IP, load balancer IP. So that's the use of Meta LB. So we have a bare metal cluster now. So we are trying to create a load balancer. So we have a problem now. We are seeing that it's pending and it's not able to assign the IP address. So to address that problem, what I am going to do, I'm going to create a service called Meta LB. So it's going to create bunch of files. That's fine. No worries. We can solve that. So basically, what is Meta LB? It is mainly for assigning the IP address. So any guess in which layer this works? Layer 2, layer 3, layer 4, layer 5? Any guess?
L3.
3.
Okay. So basically layer 2, just an IP assignment. Nothing with port. Okay.
It works on data link layer.
I think it only works on the IP assignment. So IP is at layer 2, isn't it?
I think 3, 4 is ports.
Just a minute. Let me check once. Yeah, so it's the layer 2 only. Because it only does IPv4 and IPv6. Okay, so it works only on layer 2 mode. So it just assigns the IP pool that we define in. Okay. So it's not the layer 3. Layer 3 will come in BGP. So border gateway protocol will come in layer 3. So where load balancing across nodes and all will come in layer 3. Still the same IP concept, but layer 3 will have additional intelligence, like it can reach different IPs across nodes. So that supports BGP. But layer 2 does not have anything to do with these cross node access. So it's just the IP assignment from the IP CIDR that we are giving. Okay. So it basically works at layer 2. So there is no router config, there is no load balancer config, everything is done in layer 2 level. So that's why it is at layer 2. So let me check what happened now. So I have deployed the Meta LB service. So let's see the architecture, what it does. So every tool that you install will have a architecture, right? Will have a mechanism how it is working. So basically there will be a lot of workloads that's running when you install any Helm charts. So basically for this Meta LB, there will be a controller. Let me see whether I have captured it somewhere. Yeah. So the Meta LB, it has few core components, which is controller, which is mainly for your IP allocation. Okay, it watches when you create a load balancer IP and then assigns the IP from the IP pool that you are defining it. So this is the work of the controller. So if you see the pods that are there in the Meta LB system namespace, so you will see controller and speaker. So controller is the one that assigns the pods from the IP CIDR that we are giving, and speaker is the IP assignment. So it says that I have assigned this IP to the network, so this IP is unavailable. So the next IP or the rest of the IPs will be assigned for next set of load balancer creation. So for what we have done, we have created an Nginx service, and then we have installed Meta LB. So before Meta LB, our Nginx IP was not provisioned. The load balancer IP was not provisioned. Okay, but I have installed MetaLB, but still I don't see the external IP assignment. Why is that? Because we have not defined the pool of IP to take, right? So we have to define the IP, then only it will work. So we'll have to define which range of IP has to be used for load balancer. So we have to create a IP address pool YAML, then define the addresses, and then these are the IP address that will be taken when you create any load balancer. Okay, so you will have to apply this, then only your IP assignment will work.
Ma'am, can't we use cider range instead of the hyphen?
Yes, you can. I don't have a big cider range. I have some few IPs left in my cluster. So that's why I'm giving start to end IP. If you have more bandwidth and then in the IPs, then you can provide. Definitely, yes. Cider should work. Okay.
Like, how do you decide the range of IPs to use this?
So it's based on how much IP that you have. So basically, if you are going to use only load balancer for exposing your application, that means you are going to create a lot of load balancers, right? You are not going to stop with one load balancer. So in that case, you will have to have a big load balancer. So this is not going to be the case anymore. So this was the case 5 years back. People were using load balancer. So that time Ingress, Istio and all is not so famous. So that time they were all using this, relying on the load balancer. So I have seen a customer who was having thousands of load balancers. So then that became a bottleneck. Then they have migrated to Ingress controllers. So be it any Ingress controller, that's the advantage of stopping this load balancer IP. So for my use case, how many Ingress controller that I need, or how many load balancer that I need, based on that only this IP CDR calculation will be made. Okay. So if your cluster is going to use only 1 or 2 load balancer IP, then you can have a smaller range of maybe, but don't go with single IP, because you never know, you will have a different ways of migrations, or so you'll have to always choose few IPs, at least I would say 32 or 64 IPs assigned for this range. Okay, so there is no hard count like how many IPs has to be assigned. So it's based on your organization needs, you have to decide. Okay, clear?
Yeah.
Okay, so now I see that my load balancer has picked an IP. This IP should be from this range. So first IP it picked for my load balancer service. So the load balancer is assigned now. So far it was being pending because it didn't have a mechanism which IP it has to assign. So now I have picked my cluster that this is going to be my public IP, and then I've instructed my Meta LB to assign the IP address from this range. So after installing the Meta LB, still my IP was not assigned. So then I have to configure the IP address pool to get the IP assigned from the range that I've specified here. So this can be smaller or larger based on your organizational needs. Okay, so I would say to decide based on your organization needs, and it has to be at least 32 to 64, even if you are using Ingress controller, because you might have to do a migration, and if someone wants a different Ingress class, then you will have to have a different Ingress controller. So that means you have a different Ingress IP. So if you are using Istio and Nginx, 2 different IPs are required. So in that case, definitely you need more than 1 load balancer IP assigned. So that's why I'm telling you to configure at least 32, so that you will not end up in a deadlock that you'll have to do a migration, or you have to expand this CIDR. So that's always possible. Yeah. So now it has assigned a load balancer IP. So what's next? So now I'm going to test whether my load balancer IP works. So I'm going to log into my pod. So I'm going to create a debug pod. And then to connect to this application, I'm going to call this IP. So I think this is my load balancer IP 200. Yeah. So you will not access the application using IP. So you will access the application using the DNS. So domain name server. So basically you will have to have a mechanism to host an application. So app.matrixcube.com. For example, that's going to be my application. Then that application will be mapped to this load balancer. So anything that's coming to that domain, it will be passed on to this IP address. So this IP address will be present in your cluster. So basically you will have a URL assigned for this IP. Okay. So if you see, you are able to access the application using the load balancer IP. Okay. So this is my load balancer IP. And then if I hit the load balancer IP, I'm getting a response of Nginx, which is my application. So which is my Nginx application. Okay. So that's the response that I'm getting. So now the load balancer works, but we already know what's the problem with the load balancer. Okay. So let's see how we can address this. So like this, you can create n number of load balancer, and you already know what's the drawback of using these load balancer, right? So now let's dig deep into the Ingress controller. So now can someone tell me what's the advantage of using Ingress controller rather than having load balancer? Can someone do a recap?
Instead of creating n number of load balances, like for n number of applications, we can just use an Ingress controller like Nginx, so that we can do the path-based routing.
Okay, exactly. So basically, we have Ingress is an API object. Okay, API object means it is going to be your CRD in your Kubernetes cluster. So what it is going to do, it is going to manage your HTTP or HTTPS traffic. So HTTP and HTTPS traffic to your cluster. So this is what it is going to do. So mainly for routing, Ingress routing. So any traffic that's coming outside of your cluster, it is going to hit this Nginx Ingress controller, and then it will be routed to your cluster. Let me see if I have some diagram to show. We have seen most of it for the Meta LB. Let's see for the Ingress controller. So from internet, we will receive traffic to load balancer. So in our case, we have created a Meta LB, and then that has provisioned the load balancer for us. Okay. So in cloud-based environment, it is going to be your cloud load balancer. Okay. For example, if it is an Azure, you will have an Azure public IP. Same goes for AWS. So AWS public IP will be assigned. So that is going to take care of this load balancer creation part. But for fine cluster and for self-managed cluster, we have a tool called Meta LB, where we will decide the IP address range, and then that IP address range will be assigned for your load balancers. Okay, so this part is clear. So now we are jumping into the Ingress controller. So where you have the IP already. So it can reach to that, the traffic from external world can reach to this load balancer, and from there it will be forwarded to your Ingress controller. So basically this is going to be your IP. So this IP is, I think we have not deployed in Ingress yet. In a moment we will deploy the Ingress IP. So this is going to be your Ingress controller IP. And then you will have an application called Ingress controller, which will forward the traffic. And both HTTP and HTTPS traffic will be forwarded, but internally it will do the TLS termination. So that SSL termination will happen from your Ingress controller. Basically, will terminate all the traffic from HTTPS and it will be forwarded as HTTP traffic within your cluster. So it will do that, and then there are different methods of routing. So what you can do, for example, I have app.matrixcube.com. So this is my application. So do you think that I will have only one endpoint for your application or different applications itself? No, right? So for a company like volvocars.com, they will have mostly one or two endpoints, but those endpoints will be sending traffic to all of their applications. So how it is done? It's based on path-based assignment. Like /API means it will hit the API service. /frontend means it will hit the front end. And /swagger endpoint, then it will reach the swagger. Yeah, and much more like /video, /images, all these will be separate application. So based on /path, it will be your path-based routing. So based on the path that you define, it will reach that particular service. Okay. For home service, you will have a separate page. App.matrixcube.com will have its own home page. And then if you hit a /API, it will reach your API service. So that's called your path-based routing. So based on the path, you are defining and routing the traffic to that specific service. So now you can have only one IP and then one application endpoint, but different paths to route the traffic. Okay. So that's called your path-based routing. So this Ingress controller works at layer 7. So it not only knows the IP and port, additionally it can do path-based routing as well. So that's the advantage of using Ingress controller. So path-based routing is possible, and also you can do much more like header-based routing is also possible. So there are a lot of advantages of using Ingress controller that we will see. Okay. So basically, it does this Ingress controller, it does the smart routing. So URL-based, domain-based, /path-based, all these are possible with Ingress controller. Okay. So any request that comes from internet, it goes to the load balancer, and again, load balancer will be tied to the Ingress controller, and Ingress controller, based on the path, it will send the traffic to that specific service, and service will in turn send traffic to the active endpoints, which means your pods. For example, if your service has 3 different replicas, so whichever, based on the round robin or whatever algorithm that you have defined in the Ingress, it will route the traffic to that specific pod. So you can control that algorithm, traffic routing algorithm. So by default, it will be round robin. Or you can also do connection-based traffic forwarding and random-based traffic forwarding. Different types of traffic forwarding methods are available. So by default, it should take round robin. If you want specific request to reach the same pod every time you hit, so then you have to change your algorithm other than round robin. Okay. So those are different. There are a lot of algorithms available for traffic routing, but that is basically they don't do it specifically. But if you have any use case, then you can configure the algorithms based on your traffic routing needs. Okay. So basically, this Ingress controller is the one that checks the rules and then it routes the traffic accordingly. So that's how it reaches your pod. So before this session, we were only having services API. So maximum what we will have, either NodePort or load balancer service to route the traffic to pods. But now in front of this service, you have one more component called Ingress controller, and Ingress controller is tied to a load balancer. This load balancer can be of any cloud load balancer, or in our case, it is Meta LB load balancer. So basically, this is your public IP where your internet knows to reach your cluster. Okay. And this IP will be mapped to another layer called DNS. So in the DNS only, you will mention app.matrixcube.com URL should point to my public IP. Okay. So I think I should have added another entry here for DNS server. So then from there, it receives the traffic from internet. Okay. So this is the flow. Any query in this?
Ma'am, I understand what is the load balancer and what is the ingress controller services, but difference between the ingress and the ingress controller, I am little bit confused. Like use the ingress and the ingress controller, like differences.
Sure. I think we are going to see an example. That's fine. But the concept you understood, right?
Yeah. And then one more thing, like on the load balancer, we handle the traffic, okay? And when it comes in the pod level, so the traffic will handle with the help of IPVM or IPVS, right? Like how the traffic will flow in the container level.
That is where our queue proxy comes into picture, right?
Okay, yeah. Can you just like once you have a time, can you just explain the full overview of like how the process traffic will?
Okay.
Yeah.
So basically, from ingress layer falls from internet to your service. So starting from internet to your API service, your ingress will do the routing. Okay. So your ingress controller will take control in this layer. So until it reaches the service. Okay. But when it comes to service to pod routing, then your cluster will take care of it. So if you have queue proxy, then queue proxy will send the traffic to the respective pod, whichever is alive, it will send traffic. So in case of Cilium, so we have Cilium does this service routing, right? So Cilium will take care of this service to pod routing. Yeah, I got your point. So maybe we will see where these tools will fit in. So it is not going to be a difficult job to map in, but yeah, so we will cover it. That's fine. So, but for ingress controller is the master component here. Okay. So let's see what's ingress resource. Basically, this is not your deployment or anything. So it is going to be your virtual. So we don't have any pod for this ingress resource. I'll tell you what is ingress resource when we deploy an application and then route the traffic. Okay, this is required where you are configuring this where you are configuring this /API. So all these has to be configured somewhere, right? So that's called your ingress resource. Ingress controller is the pod. Okay. And your ingress controller is where you define these path-based routing or host-based routing, load balancing options that I was talking about, and your SSL termination, CQA. So all this configuration has to be done somewhere, right? So those configuration is your ingress resource. Controller is the master component that does all the jobs of routings and all. The ingress resource is your YAML file where you will configure the routing rules. Okay. So basically, Nginx Ingress your reverse proxying mechanism where it will receive all the traffic and then you will do terminations and then traffic forwarding to your backend service. So all these are the role of Ingress controllers. And this basically it is done using the Ingress resource, Ingress YAML, where the routing rules, everything will be configured. So what is the feature of Ingress controller? It does the path-based routing, host-based routing. It can do the SSL and TLS termination. So HTTPS traffic will be forwarded as HTTP traffic. That's called your TLS termination. And then you will do HTTP traffic routing or HTTPS traffic routing, and you can do the load balancing as well. Yeah, so these are the features. Okay, let's see the lab. Yeah, did someone raise any question?
Yeah, Lavanya, I had the same question as what Priyanshu asked, but a little bit more on that one, right?
Yes, we are going
follow-up
to.
question.
We have not installed the Ingress controller at all.
One quick question. Let's say I'm doing a banking payment. Okay, let's say I'm making a GPay, UPI payment or something. Okay, so when the payment button is hit from the customer side, and let's say it goes to a banking transaction via internet, and then it goes into a banking system via external load balancer, and then it goes directly into the Ingress or the load balancer. External load balancer, and sometimes people will have internal load balancer also, and then it goes into Ingress controller. And then that path will decide, let's say /payment is the route. Then it allocates some resource. Then it goes into that service, which is nothing but a cluster. Kubernetes, still a Kubernetes cluster for that service, right? And
Mm.
then it internally sends, it decides to which pod is active, and then it sends the traffic to the pod. Is
Yes.
this flow correct?
Yes, exactly. So this, so basically you have repeated the same flow. Additionally, what you have done, this load balancer can be sometimes private or public. Okay, if you are using a public private load balancer here, but still in front of this, you need another public load balancer. So that's the logic change that you have said, right?
Okay.
So basically, if you can have a private load balancer as well. Private load balancer means within your organization or within your network, only it knows. So that's your private load balancer. But when it comes to public load balancer, it is your public IP.
Okay. So in this flow, the confusion is that Kubernetes cluster is mapped with dots, right? It includes all these things. So when we say cluster, we thought like, okay, for services, we'll have cluster and then it has multiple parts. So we thought in that way. I thought in that way. But when it mapped with the dots from the load balancer itself, then I thought, how come everything can be inside the Kubernetes cluster?
So basically from internet, you will go to the DNS server, right? Your app,
Yes.
where your app is assigned to one IP. So this IP will be your public IP. Okay. This has to be your public IP. Your DNS server is going to be internet facing, right? So it does not know a private IP. So it cannot resolve publicly the private IPs, right?
Yes.
This public IP has to be mapped somewhere, right? So this is going to be your Ingress controller.
Okay.
And this is Ingress controller. So this will have a load balancer. Ingress controller means it is a load balancer.
For now, it is Nginx, right? Okay.
Yes, for in our case, it is Nginx now. Yes. So this load balancer. So now your public IP is being received. So sometimes what we will do. So this this flow can be modified as well. I'll come back to that. But if you know this until this, right?
Yeah.
Ingress controller, and then Ingress controller will have backend service routing. So backend service routing, and again, this will go to our pods. So I will say just one pod for now. So this can be tweaked. So how this can be tweaked? So for example, I will say for an Azure DNS server. Okay. Azure DNS server, and I have to map an IP. Azure DNS server, and in the Azure DNS server, I have an application called app.matrixcube.com. Yeah. So MatrixCube is my company, so I will refer that. Azure DNS server, this IP will be mapped to either a public or a private. So public means public IP will be assigned. Private means again have you anyone heard of application gateway or Route 63 service?
Route
Sorry,
53.
Route 53. Sorry. So these are the DNS services, right? So application gateway is one of the front end to send the traffic to backend, different backend pools. So in our case, this application gateway can be configured to send the traffic to private IP. So here this logic can be tweaked. That's what I'm saying. So here we have a DNS server. Consider I have an Azure DNS server. I have an app. That app is pointing to a public IP. Okay, for example, this is public IP flow, I would say. So this public IP is a application gateway or Route 53 IP. So your public IP will travel to application gateway, and then this application gateway will be mapped to your private IP. Private IP means known to your organization. And here in Ingress controller, you can map your load balancer as your private IP. Two ways. So this is public route, this is private route. Okay. Let me clarify it again. So far, this is not even coming into your Kubernetes picture. So this is all outside, right? Any doubt in this? So this is all happening outside of your cluster, right?
Yes.
Are we clear up to this point?
Yeah.
So this is not done from our side. So Ingress controller, we are deploying it. Okay. So we are not creating a new IP IP here. So we are just mapping the IP that's either a public IP or a private IP. Okay. Clear? So in our case, for Meta LB for kind cluster, I'm going to use some dummy IP. But in production case, either it will be a public IP or a private IP. So if it's a public IP, your DNS server will have a domain. That domain will have a public IP. Okay. So to make it more clear, like here you will have a Ingress controller. Okay. Controller with public IP. So forget this flow. Let me delete it. Yeah. So public IP or public IP means directly it will come here. Okay. So are we clear? I'm not so good at drawing, but yeah. So in the DNS server, we should map some public IP. So that public IP can be directly mapped to Ingress controller. And again, this service flow will come into picture here, service and pod. This is clear, right? So this is going to be within your cluster. So from here, our cluster takes into control. So from here, our cluster will take control. So either assigning public IP or private IP, it's based on your organization. You raised a question, right? So from where you are raising your question, is it somewhere linked here or?
So you're asking me, Navneet?
Yes, you did raise a question, right? So what's your doubt in this flow?
No. Now I'm clear. Yeah. I mean, in the last diagram, you had that Kubernetes cluster mapped fully on the diagram, right? So I was a bit confused. Now I'm a bit clear on the flow.
Right. So basically, this full diagram that I was mentioning, I think it's so we didn't have all the DNS things mapped here. That's why it got it made you confused, I guess. So yeah. So why it was mapped inside the Kubernetes cluster? Because Ingress controller is mapping to the load balancer. So that's why it is within the cluster. It is mapped in the architecture flow. Okay, but this IP is not created within your cluster. It's actually from external world. It's a public IP, right? Okay, are we clear with this logic? So we have two flows. Public IP can be mapped to Ingress controller or private IP can also be mapped. But before private IP, there will be a public IP. That public IP will come from application gateway or some other mechanism of routing the public IP to private IP routing traffic. Okay. So two flows. Let's continue with the lab. So now I'm going to install Ingress. So either you can install Ingress using this YAML or you can use Helm chart to install. So both are same. So if you see 200 was my previous IP, that's for my load balancer, and 201 is my Ingress controller's load balancer IP. Okay. So using this IP, our application will be accessible. I have deployed an Ingress controller. Let's see the architecture of Ingress controller, what component it deployed. Space, space, Ingress control. Didn't deploy anything even. Okay, it's still deploying. But anyways, our service is already up. That's fine. So it has assigned an IP. It would take some time. Let's see meantime what we have. So now we have deployed Nginx Ingress, and then we are going to see what's Ingress resource. So I'm going to apply ingress.yaml. So before that, we'll have to see what's there in the Ingress. So basically, what we need for an application to be deployed. So we need a deployment file, right? So we need a deployment file. We need a service file to expose the application within the cluster. So without service, even your Ingress will not work. So for any application, you need deployment and service file. So I have two services getting deployed. One is just Nginx. Another one is called API app service. So two apps I'm installing currently, and then two services. So these are my YAML that I'm going to deploy now. So additionally, it will have one more component called Ingress. So one more manifest called Ingress manifest. So where you will do the traffic routing. So path-based routing, everything will be done from this file. So this is your Ingress YAML. So if you see it in the picture, this is your Ingress resource. So you see the component that it deployed, it only had Ingress controller. Okay, so Ingress controller is my component or the master that does all the routing, but who does it? Through Ingress resource. So what's Ingress resource? This is going to be your Ingress resource, and then you can name the Ingress resource as you want. And then you'll have to, for every Ingress deployment, it will by default create an Ingress class. For example, if I'm using an Nginx Ingress, it will be my Nginx Ingress class. If I use an Istio, this is going to be my Istio Ingress class. So based on this Ingress class only, this routing will be picked up. For example, if in this case, in this picture, so we are using Ingress class called Nginx, right? So that means your Nginx Ingress controller will be picked up, and then it will route the traffic. For example, in my cluster, I have two Ingress controllers. One is Nginx, another one is Istio. So in that case, based on the Ingress class, it will route the traffic. For example, I have few set of application using Nginx Ingress, few set of application using Istio Ingress. In that case, based on the Ingress class configuration, the right Ingress controller will pick up the traffic and send the traffic to the backend service. Okay. Yeah. So I think someone asked about the Ingress resource, right? So this is what the Ingress resource is. So what you are seeing that you will see the Ingress class, and then you will see the rules, routing rules. So for HTTP, for /path, it will send traffic to my app. So which is this. So for /path, it is going to send the traffic to this deployment. So this is my service, right, for that deployment. So app, my app. So for that service, it's going to deploy. So service name is my app, which is this one, right? So it's going to send the traffic to that service at port 80. And if I have another application called API, so for /API path, it will send the traffic to API service, which is this one. That is API service, yeah. So this is API service. This is the second service. So for /API, it will send the traffic to /API service. Okay. So if you have consider 15 or 20 services, then your Ingress file will be large, or you can split it into different Ingress files. You can create 10 Ingress files as well, and then create a path. So, but there should not be a clash. Okay. So two different applications with two different URLs should not have two different paths. I mean, sorry, same path mapping two different services. So I have an Ingress file like this, and I can have another Ingress file as well. And then if you have the same, instead of /API, yeah, something like Swagger, if that is going to send the traffic, then two services will be pointing to the same. or else if you have /API and then sending traffic to some web service, it's going to create a conflict. So basically you will have a host mapped here as well. For example, I think somewhere here, it will have the host called app.matrixcube.com. So for this host, for root routing, it will send the traffic to my app. For /API, it will send the traffic to web. So, but if you have another incorrect routing of /API sending another traffic to a different service, then there will be a conflict. So when you are defining the route, you have to be very careful. Two different applications can send traffic to two different services. So this you need to monitor when someone is onboarding. Okay. So this you will have to keep track. Okay. So now let me deploy this Ingress. Are we clear with the Ingress resource?
Yeah, I understand the Ingress resource, but still confused the Ingress control, like where we configured the Ingress control. Like as we see, like we copy the command, but what it does, what it is doing, or like do we configure the Ingress controller? I'm little
Basically, you are installing the Nginx Ingress, right?
yeah.
That's your Ingress controller. If you want to see what it is doing, you can check these logs. So it is going to do the traffic routing. All the traffic routing will be mapped here. So if someone is accessing my application, I can see the entry in my log. Okay.
So with the same thing, we cannot do with the load balancer.
Yeah, where you will see the log for load balancer. No, right? We don't have any application to see the log.
Okay, so that's why we're using the controller. Okay.
So for every application that you are deploying in a cluster, in a Kubernetes cluster, it will have controller doing all the jobs of routing or yeah, for every application. For Argo CD, you will have an Argo CD controller that is doing your job. For Istio, you will have Istio controller. So Kubernetes will have a Kubernetes controller. So every component will have controller doing the job. Okay. So if you see the pods, it will have a controller, and then you have to follow these logs. So just maybe it's very hard to understand at the beginning, but as you go, first thing, if there are any problem in your routing, where you will see. So you will have to check this controller logs. So this is going to tell me what is the problem. If I hit any URL, this log will have such information. So whether the application has been accessed, so which route it has been, it has sent the traffic to. So all the details will be present in this Ingress controller log. Okay.
Then describe, we use kubectl describe, right? What's the difference between the describe and the log? Like, what are the logs we'll see in the describe?
Yes, why not? We will see it right away. So in the log, what you are seeing, I am deploying an Nginx controller with the release, and this is my Nginx version. And then it also told me any errors, whether it has started the Nginx process in my container. So all these details are shared. All these details are logged, right?
Yes.
Clear, right?
Because I think till now I have seen if there is any issue, we can see that using the describe option.
So now this is your describe command, right?
Okay.
What it is describing, it's describing my deployment file. It's describing what I'm describing a deployment file called Ingress Nginx controller. So this is going to tell me my configurations, my Ingress configurations. Okay. So this is not going to show me anything that this application is doing. So whatever is your configuration, it's going to just show the configuration. Okay. So first thing, so kubectl get deployment. So whatever you deploy using the kubectl apply, so it's going to show that. Okay, so this YAML If you describe it, it's going to show me the same thing, but just the format will be different.
Yes, but the message tab which is at the bottom, right? So if there is any error coming from the deployment, then we can see the error message in the describe as well, right?
Right.
If it is not scheduled or something.
Yes.
Yeah.
So when you will see the log, so when your application is in running state, then only you can see the log. So if your pod is, my client cluster is not responding, but that's fine. So you have seen kubectl get pods, right? So
Yes.
before the pod is in running state, what it will be in? It will go in pending state, and before that, it will try to pull the Nginx image. So all these details before running state, if you have any problem, then you will see that in the event. So this is the event that is getting logged for every action that is being taken onto the resource in the cluster. Okay, so that's called the event. Okay,
Yeah.
but once your application is going into the running state, then what will happen? Then your controller is up and running, right? So then still sometimes your now if you see your application is running with /1 bar 1, which means it has started successfully. Sometimes you will see 0 bar 1, means 0. This is the container number of containers that your application is running. Okay, my application is running only one container, which is Nginx container. That Nginx container is up. That means 1 bar 1. So if your application is down, you will see 0 bar 1. Okay.
Yes.
Still sometimes you will see running state, and then continuous restarts will be there in case of crash loop error. Right?
Yes.
So in that case, do you think describe will help you? So describe will help me if I miss any config map, if I miss any secrets that is referred here. So it will give a message in the event, because before the application starting, if there are any configuration problems, like config map that you referred in your deployment is missing, if a secret that you are referring in your deployment is missing, if you are creating a volume, for some reason you don't have a storage class, or the volume is not able to provision, that type of details you will see it in the describe command. But logs will give me if there are any crash loop, what is because of what error I see a crash loop error. So that type of details, it will be there in the kubectl logs command. Okay, so
It's
that's
like before scheduling the pod, we can see the logs in the describe, whereas after scheduling, we can see those in the logs.
Basically describe is not log, so you should not call the describe as log at all. So it's just describing your configuration, deployment configuration. If there are any problem in your configuration, then it will show the problem there in the describe command.
I have seen like if there is some problem with the storage class also, I have seen those logs in the describe actually.
Yes, that is your configuration issue, right? That's not your application issue.
Oh, okay.
Okay,
Yeah.
that's your configuration problem. So now tell me, I have a deployment. I have a volume that's created, right? That's getting created. And I also have a storage of a service account that is mapped in my deployment. I don't have a service account that's created, but I refer that service account. So then that will be your describe or your log, where you
Describe.
right? Describe. So configuration problem. That is
Got it. Yeah.
that's your describe. But do you think that it will be in the log? No, right? It's not even in starting phase. There is
Yes.
no running phase. There is no crash loop. There is no container config error. So those details you will not see there. So all the container related errors that you will see it only in the logs. Clear?
Yeah, got it. Thank you.
Yeah. So I'm going to deploy this Ingress. Let's see if my Nginx response. Ingress. Can someone run the lab for me?
Yes, sure.
Oh, thank you. So it's in week 5.
Yeah.
Yeah, in the meantime, so can I ask a question? Actually, you told you will be giving the configuration of load balancer in the Ingress controller, right? I don't see any of the configuration in the Ingress controller YAML. Don't we do it like explicitly?
You are right. So basically, how we deployed Ingress?
Mm, as a controller?
Is right, but how? So we
Using
deployed
a
it here, right? We deployed it from here. We deployed it as a declarative way.
Oh,
Okay. So by default, if you don't specify IPs, it will take a random IP. Okay.
okay.
So here, if you see, this is the YAML that we deployed, right?
Yes.
So what type of load balance, what type of service I'm creating? It is a load balancer, right? I did not specify any IP. So that means my meta LB is the one that's assigning the IP which is available in the pool.
Okay, that should be matched with the Ingress controller, right?
So
I mean, like that should be mapped with that.
that should be mapped,
Yeah.
but not necessarily. So if you have a default IP that can be assigned in your cluster, you don't need to map it at all. But in case of cloud load balancer, you will have to pass the IP, either pass the IP or pass the annotation. For AWS, you will have to pass it as annotation. I think for AWS,
Yeah.
you will see something called AWS internal load balancer or something. So that annotation you'll have to pass to pick the AWS public IP. In case of Azure, you just map the IP. So here in this service YAML, I will map an IP. So like in the load balancer IP section, I will map a hard-coded IP. So that IP will be configured for my load balancer. Or either you can map the IP or I can say Azure internal load balancer, which means from my cluster subnet, it will assign one private IP, which is this flow. This
Okay.
flow. So either public IP or private IP. Private IP means you'll have to add one annotation in case of cloud load balancer. So for AWS, it will be AWS internal control IP, I guess. For Azure, it will be Azure internal load balancer. So that service annotation, if you add it, automatically the public IP will be assigned. Public or private IP will be assigned. Okay.
Okay. So this will be in the Ingress resource YAML, right?
This will be in the service YAML.
Service YAML.
So we are not going to do for every Ingress resource. So Ingress resource is required for every application.
Yes. Yeah.
So just a minute. I think we are getting confused here. Let me draw it again for you.
Ma'am, are you sharing your screen?
Is it not visible? Oh, I did not stop. Okay.
Actually, we
One
can see
second.
Priyanshu's screen. That's it.
Okay. Yes, Priyanshu, you can go ahead and complete the lab. Meantime, I'll clarify this question.
Yeah,
Okay.
I have created the ingress and the deployment.
Okay. So where are you now?
I have created the ingress.yaml. I run the command.
Okay. Can you go ahead and share? Let's finish up the lab and then take this question.
Sure.
Mostly we are done. We are going to just see the routing. So how it will be for /API, how it will be for home page. So similarly, you will have n number of host-based URLs mapped. The traffic will be routed accordingly.
I just run the 44 line command kubectl apply -f ingress.yaml.
Okay. So then, can you do one thing? Can you port forward this? Port forward Ingress service. If you don't have, I'll send it. I thought it should be there. I exposed it. I think it's not there. Let me port forward the Nginx and then give the command to you. Port forward service slash and your Ingress service name.
Okay. Ingress controller.
What's your service name? That's
Yeah.
the one. And you have to pass the namespace.
Okay.
Like, yeah, -n namespace 8080 slash colon 80. So it's not 443. Okay, your Ingress port is 80.
Okay, and what is the namespace? I think.
Namespace is Ingress Nginx. Ingress -Nginx. So what are we doing now? We are accessing the Ingress controller IP, basically your service IP, which is your, consider this as a public IP. Okay, you're accessing this public IP. Can
Yeah,
you?
it's
Huh? So
yeah,
now,
it is okay. I just hit the curl command.
okay. So it, without giving any /API, it is giving me your homepage, Nginx homepage, right? Can you do /API?
It shows the pod API app.
So now this is your path-based routing.
Okay, this one. Okay. So 1 second. Okay, so it shows like it is hitting the traffic on this container.
Right. So go back to your ingress.yaml and scroll up. Scroll up. Yes. So by hitting the home page, what it was giving me by the ingress page, right? The container, yes, this one. Basically, yes, this is the application. That's the home page of my application. So if I hit just /, I'm getting the Nginx Ingress homepage. That is my application 1, which is this one. Okay, come down. Come down. So I have a second deployment. So this is my second deployment, right? So if I hit /API, then it is giving me my pod name, right? So I specifically mentioned to list my host name. Okay, host name in the sense here here it is the pod name. So from where the traffic is being served. So wantedly I have kept that to just understand from where the traffic is being served. Okay, so this is my second application. Come down. And then this is my service YAML for the API service. And then just revalidate the Ingress YAML. So you have hit the just the IP address. If you hit just the IP address, which service it is pointing to, line number 87. So this is your service name. That's my first service, right?
Okay. Yeah, this one. Okay.
Right. Come down. Service name, not the label. Okay. Service name. And then for /API, line number 91, for /API path-based routing, go to the line number 95. /API, it is hitting this service name, API service. So you should have one service called API service. Just to go back and check. Sometimes what they will do, they will give a different service names, and then that service name will not, service itself will not be there. Sometimes people give slash the name of the service as API, but the cluster will not have a service called API. So it will have a service called API-service. So this type of wrong mapping will be there. So because of that, your routing will not work. And then if they mention the incorrect port, then your application will not work. And then if they mention the incorrect selector in the service, then in that case, your application routing will not work. So these are some of the routing problems. So if there are any routing problems, just a moment. If there are any routing problem within your cluster, then first thing that you have to check is your Ingress YAML. Second thing you have to check is at least your port forward of your application is working. So then check all the container ports and then label, application labels, all these has to be correct. So this is where the problem comes when the traffic has hit your cluster. So such type of problem will come only if it is hit in your cluster. So before this, what could be the problem? So if you have a routing and then you check your ingress is correct, your application YAML is correct, the deployment service, everything is correct, and your port forward is working, and port forward of your ingress is also working, which means what could be the problem? The problem is outside your cluster, which means your DNS server is not configured properly, right? To reach this IP, to reach this load balancer IP. And then check your ingress assignment, check your DNS assignment for your application. Like app.matrixcube.com is having the right IP assigned. So check the NS lookup for that application. So which IP it is assigned. And then check in your DNS server that IP is properly mapped. So all these configuration you have to check. So basically troubleshooting the routing could be one of the day-to-day operation. So you have to isolate whether the traffic problem is before reaching the cluster or after reaching the cluster. Before reaching the cluster, you have to check externally apart from your Kubernetes cluster where the problem is, and then you have to rectify it there. So after reaching the cluster, if the application is being hit, like Ingress, until Ingress controller, your traffic has reached. Then your application is not served, means your configuration could be one of the problem.
Okay.
Is it okay? Is it clear?
Yeah.
Right. So, Poluka, you have raised a question, right? I completely forgot. What is that?
It's regarding the routing between load balancer to Ingress.
Load balancer.
Ingress controller. I mean, like mapping basically.
Okay. Yeah, I think you have asked about the IP assignments, right? For the Ingress controller.
IP assignment. Like basically those 2 points, linkage of those 2 points is little bit confusing.
Just
Through Meta LB, yeah, through Meta LB, the IP will be assigned for the load balancer. That's clear. But that IP should be assigned to the what do you call Ingress controller, right? How those mapping of load balancer IP to this is happening is my question.
Okay. My screen is visible, right?
Yes.
I'm just taking a shortcut. You can check this in Helm chart. So I can install the same YAML using Helm chart as well, right?
Yes.
As we have seen in our previous class, in the values.yaml, what you can do in the service, if you don't mention anything, it will just take the IP from your cluster configuration, like take the cluster IP from your subnet. Okay, but if it is a public IP, it cannot take the IP from your subnet, right? It has to be a public IP.
Yes.
If you don't have any public IP mechanism to assign, then what will be your status? It will be in pending,
Yes.
right?
Yeah.
But if you have a possibility to assign the IP, so in our case, Meta LB has taken care all the load balancer IP assignment. Any load balancer if I create, it is going to assign an IP for me, right?
Yes.
So that's why I did not give any configuration details here. It took the IP from my Meta LB. So Meta LB had a configuration where we have said from this IP to this IP, you assign an IP allocation whenever there is a load balancer request comes in. So this configuration has taken care for our kind cluster. But in case of cloud load balancer, you will have to have this annotation. I was talking about the annotation, right?
Yes.
So this service annotation has to be there. So is it a Azure load balancer internal or external? If it is an internal means private IP will be chosen. So if it is an internal, this logic will come into picture, right?
Yeah.
If it is an external, this logic will come into picture.
Okay.
Okay. So if it is a internal, from where the IP will be assigned? Here, if you see service, so this is going to be my annotation format for Azure. So similarly, you will have one for AWS. Okay, Azure load balancer internal true. So it is a private, right? So private means it's coming from your VNet.
Yeah.
Okay, it's coming from your virtual network. So from which subnet it has to take? You have to give the subnet name. Okay. So how this subnet will be identified? Your cluster will be created in a VNet, right?
Yes.
So your cluster will have a VNet and your cluster will have subnets, multiple subnets.
Okay.
Just a minute, let me draw that for you. So I'm creating a AKS cluster. So for creating the AKS cluster, what you need in terms of networking, I need a virtual network, right?
Yes.
So virtual network is nothing but a CIDR.
Okay.
Yeah, just pardon me for the spelling mistakes. So each and every VNet will have subnets. Subnet means dividing the full CIDR. Okay, I have a big CIDR range of 256 IP, and then I will divide the 256 IP into 4 different subnets. So subnet 1, subnet 1, I will have 64 IP assigned. Okay. Similarly, I will name it as for nodes. Subnet 1 for nodes. And subnet 2 for, now you tell me what will be my subnet 2 for?
Services.
Load balancer.
Okay. So this will be my subnet dedicated for my private load balancer. So for this, we are assigning one subnet. So that subnet will have 64 IP addresses. And in my Ingress configuration, what I have defined, Ingress load balancer true, and I have to map my subnet name. Okay. If I map this subnet name, it will take any IP in that range. Any one IP from 64 IPs that I have defined. Is it clear?
Yes.
Either you can pass the load balancer IP directly, or you can just map the subnet. So any one should be enough. So you were asking about how this public IP assignment will be mapped, right? So this is for private. Okay. For public IP, how it will be, you don't need annotation at all, right?
Yeah.
What you can do for public IP, you can just mention the public IP. That's it. In the service, load balancer IP, public IP. So that's what I was saying, where I have to do it while deploying the Ingress controller. All these configuration has to be taken care. If you don't have any configuration that you are doing, it will take the default IP, whatever is available. In my case, it's meta LB. If I don't specify anything, it will go in a pending state, in a production case, in Azure or AWS. Then you will definitely have to use this annotation or load balancer IP mapping. So here I have to add one more config called load balancer IP and then assign the public IP. Clear? Okay.
Yeah, got it.
So I think I have a session maybe in the next week, I guess. In week 6, I have Orco CD. There also I'm installing Ingress. Okay. So maybe I can do this there. IP assignment. Just as a recall, we can cover it again. If you have any queries there, we'll cover it. Okay. So I think we can close it for the day. So today, can someone recap what we have seen? And also I want someone to tell me what's Ingress controller for? What is the advantage of using Ingress controller over load balancer? Can someone recap? Priyanshu, can you take it?
Yeah, sure. So, like, can you just ask me the question? Can you just come back?
Okay. So why do we need Meta LB?
Meta LB is for like Meta LB is for like suppose if we want a load balance on our bare metal, so that's why we use the Meta LB.
Okay.
Yeah.
So in cloud environment, do we really need Meta LB?
No. In the cloud environment, we have a multiple load balancers. So according to our needs, we can use the load balancer like application, the network, and the geolocations.
So basically in Azure, they will have the private public IP assignment mechanism or a public IP. So that IP you can directly use. You don't need to have a Meta load balancer at all. So that this is not required in case if you are having a vendor managed load balancer IP assignments. Okay. This is optional. Okay.
Yeah.
So that's the use of Meta LB. And now we have load balancer. So we have the Meta LB created. And what is the use of load balancer?
A load balancer is for to distribute the traffic. It assigns the public IP, and with the help of Ingress controller, we can check the logs. Okay. So with the help of load balancer, we can expose our
Application. Okay.
application.
So we are not talking about the Ingress controller at all. So we are talking about the default load balancer. So it is just for exposing the application. What's the drawback of it? Again, we have seen it many times. Number of IPs, DNS management, and then no troubleshooting is possible. And also not much of a troubleshooting required. It's just the IP assignment. That's it. It's not doing any L7 load balancing or stuff like that. It's just an IP assignment. So yeah, a lot of disadvantages. We have covered it already. And then to cover that disadvantages, what we had traffic flow with Ingress controller. Okay. So today for our demo purpose, we have seen the Nginx Ingress controller. So what it does?
We can configure the path-based routing and the SLS and TLS terminations.
Yeah, I've just shared the slide.
And we can also check the logs of the traffic flow. We can check on the logs. Like on the ALB, we cannot load balancer. We cannot check the logs. If we are using the Ingress controllers, we can check the logs, right?
So every deployment, every tool that we deploy in Kubernetes cluster will have a controller. Controller is the master of doing all the works. So we are seeing all tools, right? Every tool will have a controller which has all this logics doing behind the scenes. So all that you have to do is you have to enable the feature. So for example, Ingress, you just create an Ingress YAML and just make use of the Ingress advantage of using Ingress, like path-based SSL termination, everything we can make use of it. Just you consuming that API. Okay.
Okay, ma'am, suppose in the interview someone is asked like what is the ingress and what is the ingress controller. So how much deep should we go, or like what you will prefer, like what should we tell, or like what is the definition?
So basically, if they ask you about the Ingress, so first thing I would ask you to explain is you will have an Ingress controller, right? That is going to manage all your traffic. So in the architecture, so if you have any questions, two things you'll have to answer. One is at the architecture design side, another one is at the application side, what you are going to use. So two ways you have to attack that question. So architectural components you have to explain. In case of Ingress, it will be your Ingress controller, because if someone is asking about Meta LB in specifically, so at the application side, you are going to say that it is going to assign the IP. How it is going to assign? It's going to do it via this YAML. So first thing you have to remember is this YAML file that has to come to your mind, right? Where is that? Meta LB, week 5.
Yeah, yeah.
This is at the application side, but you have to cover the architectural side as well, right? To explain. So for that, you have to remember architectural design. So what it has a controller, it has a speaker. What does a controller do? What does a speaker do? For Meta LB. Similarly, for each and every tool, you have to remember this core components and then how to use it in your application. So two ways you have to attack for every question. So if you, for example, if I ask you something about the Ingress controller, you will say path-based, you will say SSL termination, you will say reverse proxy, you will say load balancing within your cluster. So that you will say it from the ChatGPT also, right? You can query it and then it is going to give you. But how you will configure it? So whether you have a private IP or a public IP, how a private IP will be mapped, how a public IP will be mapped, and in terms of architectural, how this is being designed. Okay. So why I am taking Ingress Nginx controller as an example, this is widely used. So you can definitely refer this. People will definitely ask you, since this is deprecated, what is the plan of migration? But for that migration, you should know what's Ingress controller, right? So that's why I've taken this example. But behind the scenes, the concept will be same. It's for the path-based /API means /API service will be hit, right? So that is going to be the logic for each and every Ingress controller. So now I have explained about the Nginx Ingress. So your task is you go ahead and explore either Cilium Ingress controller or Kong Ingress controller. How to deploy it in your kind cluster along with Meta LB, you can use for load balancer IP assignment and deploy that Ingress controller and make use of application logic. Like now you have used ingress.yaml. So for that also it will have HTTP route. So that is going to be your Ingress. So that's the replacement of Ingress. So you have to use HTTP route. So for such Ingress controllers like Kong or Cilium. So explore any of this and come back with some questions maybe next week, or I don't think we'll do it tomorrow, right? So next week you do this lab assignment of Kong Ingress controller or Cilium Ingress controller. I will give you third Ingress famous controller is Envoy Gateway Ingress controller. So 3 competitors I'm giving you, and then let's see if you have any queries. The concept is same.
Okay.
So Cilium also supports path-based routing?
Yes.
Okay.
Yes, all these Ingress controller supports path-based routing, L7 layering. Yes. So tomorrow we are going to see about the Istio Ingress class, Istio Ingress controller. So it has way more advantage as compared to these basic Ingress controller. I would say these Ingress controller, which I just said, Cilium, Envoy Gateway. I think Envoy Gateway is not a basic Ingress controller, but Cilium and Kong Nginx Ingress controller. All these are basic Ingress controller. So advanced Ingress controller is your traffic, is your Istio, console. All these are advanced Ingress controller. Why I am calling it advanced, I will tell you tomorrow. Okay, that's what we are going to explore further.
I think everyone will be excited for Istio because from so many days we are listening the word Istio.
In Kubernetes,
E-
you must
even if even if you read it or do hands-on, you tend to forget it. I actually worked on Istio in service mesh on GCP.
Mm.
But after I left the project, I completely forgot.
Yes, but you should not completely forget the logic. You should always understand the ecosystem, what it is.
Yeah. But there's a tendency that people get confused with these words, right? So
Yeah, I think I'm trying to map, or I am trying to ask the questions again and again. Sometimes it's all basic, but I still want everyone to recollect, because these concepts you will not get it and memorize it, or it has to be in your muscle memory, people say, right? So you should know by now you should have known what is Cilium, right? By now you should have known what is at least Nginx Ingress controllers word, and you know what is the use of volumes. So we are trying to cover again and again, though it is taking a lot of our time. I'm trying to recollect, and I want everyone to be active. So that's why I'm raising questions, and I want everyone to answer.
Yeah, ma'am, I have one question. Like, suppose in the interview, someone is asked like how the pod-to-pod communication works. So, can we just simply say the pod-to-pod communication work with the help of cluster IP, or can you just explain me what
You
should be?
cannot just like that, Priyanshu, for these questions and all, you cannot just like that explain everything in generic terms. So they have to believe you definitely worked on the project, right? So
Yeah.
that means pod-to-pod communication. First thing you have to remember is your service mesh is second thing. So without service mesh also your pod-to-pod communication works, right? What is the answer? Q proxy.
Yeah, Q proxy.
Q proxy should be your first answer. So if and then if you want to deny the pod-to-pod communication, the network policy will come into picture, right?
Okay, yeah.
And then if you want to have a service mesh for interacting pods securely, right? Yeah. So then you will have to attack service mesh, Istio. Just like that, don't go for an advanced answers. Like just like that, don't give Istio as a one-line answer. So just you have to attack CNI level, then policy level, then come back to your service mesh.
Yeah.
So 3 different areas to cover the same.
Okay.
But you should give an opportunity to your interviewer to ask questions where you are well familiarized with. So your answer should be like that. You should not just like that. You cannot give some answers like which you don't know, right? So they will start questioning there. So if you don't know Cilium, just hide the Cilium thing. Just forget about Q proxy. That's it. And then jump to Istio. That's it. Just forget about Cilium if you're not sure. But if you can give Cilium information, then well and good. Not 80% or 60% of the people don't work on Cilium. Right? They cannot give answers with Cilium. I have taken hundreds of interviews, but hardly people explain about Cilium properly. Right? We don't know anything, but just skip it.
Okay. Ma'am, I have one more question. Like, I have a 4 year of experience working as a SRE, okay? But for last 2 years, I haven't get any technical work. Okay, so I almost forget the Git and the kubectl command. That's why I joined this course. So if someone is, so industry demands a lot of things as per the 4 year of experience, okay? So if someone is hiring for the SRE, so they want like you should be good experience in the Kubernetes. So like what should I do, or what can I what kind of projects I can create, or like what should I do
Mm,
to impress them, because they can easily check, easily catch, like you haven't have a like real time experience
mm,
on the production. I know what is the selenium, but in the production or like in the company how it works and what's the day to day activity on the Kubernetes, I don't know because I haven't worked on it.
mm,
And I have a 4 year experience, so company demanding a lot of things,
mm.
right?
For
So
4 year experience, I would say they would not expect you to be a platform architect. They would not expect you to be an architect in DevSecOps, right? So you should know all the Kubernetes ecosystem tools. That's it. I think you should be able to clear. So they will not expect you to design a Kubernetes cluster at all, right? They will test your knowledge in these tools, Kubernetes ecosystem tools. Even if you don't know the cluster upgrade process, that's fine. You can just admit it directly. Don't fake it too much. So you fake it up to you, the level you can handle. I would say, yeah, I think I'll give you tips, Priyanshu.
okay,
Okay, but for today,
yeah,
you should wait for that session.
yeah, sure.
Each and every session is important. So if you miss one session, you will miss Istio. If you miss another session, next week is going to be your Argo CD GitOps. You will miss the GitOps concept completely. Okay. So each and every week we are covering very, very, very important tools. So just try to, wait for wait for the day, I would say. Yeah.
Yeah, sure. And like before you ask us question, like what is the migration process would you prefer? Like if you are using the Nginx and you are jumping to the like gateway API, and because this is a depreciated. So this questions can be asked for the 4 year of experience.
I would say you can directly deny you have not worked on migration of Nginx Ingress controller. You are just using the Ingress controller. People will still use Ingress controller even if it is deprecated for next 6 months because they don't have a bandwidth to migrate. And then if they have to migrate, they have to take a downtime. So that's not possible at all client levels, right? You cannot take a downtime for such migration. You can directly say that you have not worked on the migration. We are still using Ingress Nginx controller. Okay.
Okay. Okay, ma'am, one more question. Like, it is a very basic. Like, someone is asked how DNS work. Okay, so I know how DNS work. There is a root server, there are authoritative servers. Okay, and the TLDs and all.
Mm.
And what is the like a TLS handshake, three-way handshakes? I know, but how much depth should we know about it? Like, should we know like how the packet will flow? Like there is a sync and acknowledge. So and like I'm just confused. Like networking
That
is the ocean, and
is not basically at the max in Kubernetes network investigation. What you would do, you would take a TCP dump to see where the packet dropped. Okay, you will log into the pod and send the traffic and then take the TCP dump. That much you will do. You will not do, as you said, you will not do packet by packet traffic filtering and all. So just visualize it there. That's it. Using the TCP dump, just visualize the traffic. Where was the delay? Where was the packet drop that's happening? That's it.
yeah. So that's thing I still don't know. So like where I can learn, or like will you take the session for this?
It's very hard, Priyanshu, to take all those sessions.
No worries. You can just give me some topics or like some references, so I will study myself.
Okay. So just explore what's TCP dump and then how to troubleshoot the traffic flow in live production cluster. There are a lot of tools. Okay. Just explore. And also there is a tool to analyze the TCP dump also. Wireshark. So Wireshark will give me what is the traffic flow, where it has dropped. So take the dump and visualize it in some UI. Okay.
Okay. Yeah, actually, I have used the Wireshark, but like while learning this, I go in depth. So I just confused like what should I study or not.
So you
Because I cannot setting my boundaries. Like networking is ocean, I think. And how much should I study as a SRE or the DevOps? I don't know. So that's why I am wasting too much time in this.
I understand your concern. That's a valid concern, Priyanshu. But trust me, unless you don't work on anything in the production live environment, whatever you learn, it will be of no use. So it's fine. Just understand how you start the troubleshooting. Then in the real-time cluster, you will know more. Okay. All that you need to do is just to crack the interview, right?
Yeah.
Yeah, that is where your aim has to be. That's what I think. But later on, you can keep on building the troubleshooting knowledge in a production live environment. So as much as you know, like TCP dump, taking a traffic with TCP dump and then visualizing it through some tool, that should be enough to start. Definitely, that should be enough, Priyanshu. You don't have to stress yourself. Just understand the concept crystal and clear. Anybody, if someone asks you what's Ingress control, you should just tell out of your muscle memory what it does. Okay, so we have not covered all part of the Nginx Ingress controller. Just to go back to the documentation and read more about it. Okay, so wherever we missed, we have not covered HTTPS at all. We have not covered the certificate management. So we are just doing some basic traffic management only. We are not doing all types, like how the SSL termination will happen. So SSL termination and HTTP traffic, you definitely need certificates. We have not seen the certificate management, right? So learn in depth about each and every tool. That should be enough, Priyanshu.
Okay. Thank you.
I think we can stop the recording. Yeah. I think we are over time. We can stop for the day and resume tomorrow.
Thank you so much.
Yeah, no worries. Bye, team. Bye.
Thanks, Lavanya.
Thank you.